Hi guys. So today I'm going to be presenting our fluid mechanics project, and we are from group 5. So for our fluid mechanics project, it is involving with water delivery system of R&R area. So this is our team: Nabil, Kenny, Aiman, and myself, Ifa. So our topic for this project, including introduction, project goals, main components, problem statement, methodology and calculation, data analysis and discussion, and conclusion. Introduction. Our project focuses on water delivery system in R&R area. The water delivery system needs to be more efficient, accessible, and sustainable for the users. We need to build a good piping system with considering type of material, equipment, and pump. This system also applying concept of mechanics fluid, such as the Bernoulli's equation, Reynolds number, and head losses.
Hi, Assalamualaikum. My name is Ahmad Nabi Kemal bin Ahmad Yunis. So today I'm going to present to you about our project goals. So there are two goals, which is first one is to deliver the water to all of the users of the system in sufficient quantity for potable drinking water with the least amount of losses and acceptable quality. The second one is to ensure that the system can work efficiently for a long period of time by calculating the head losses and appropriate pressure. So next is the problem that we have to face. There are three problems, which is the first one is the pipe leakage that causes by the structural damage to a building, which can be financially harmful. The second one is the head losses, which is the head losses due to the frictional resistance of the piping system, such as pipe, valve fitting entrance, elbow, and the exit losses. The third one is the cost of this project, because we need to reduce the cost of the suitable pipe in order to save money for the other component. So there are several main components that we use in this project, which is the first one is the flash milk tanks, the second one is the flocculator, third is the sedimentation tank, fourth is rapid dual media filter, five is water tank, six is water pump, and seven is the ball valve, eight is the intake screen, nine is the poly pipe. We use the poly pipe other than PVC pipe. We are choosing to use the poly pipe. And the 10 and the lastly the pipe component for the minor losses. So that's all from me. We move on to the next presenter. Thank you very much.
Group calculation, we use several assumptions. First, we assume that effect of sudden expansion is negligible, and then for density of water is 996.45 kilogram per meter cube. First, we calculate the volume for each component, and then we total up. We get 892.543 meter cube, and then for the area of pipe, this is area of pipe for 0.4 meter diameter pipe, and then we got 0.1257 meter square. For the average velocity, we got 0.0823, and then we calculate the Reynolds number using the Reynolds formula, and then we got the 32,691.16, which means we got a turbulent flow. And then we use formula to find the F value, and F value we got 0.0501. For the average volumetric, we calculate the volumetric for 1 day. which means 0.01033 meter cube per second. And then for the mass flow rate, we got 10.311 kilogram second. For the major losses, here this is one of the example of our question for major amino losses. For this actually major amino losses for the water reservoir pipe to the intake screen. Major losses we got 0.000173, and then for the minor losses we got 0.00054 meter, and then total up we got 0.000713. For head pump, we use the Bernoulli formula and then we arrange it. For the pressure difference, we can cancel out because it is equals to atmospheric pressure, and then for the velocity, V1 equals to V2, and then the height difference, we got 2.8 meter. Of course, no turbine involved. Then we can calculate the value of head pump. For head pump one, we got 2.84 meter, and for pump two, we got 20.26 meter. For the NSPH available, actually we use the different formula from our syllabus, as you can see here. For NSPH for pump 1 is 12.869 meter, and for the pump 2 is 7.8483 meter. For the work pump, we use the formula rho GH Q rho GH Q HP for pump 1 and pump 2, and then we could total up, we got 2.33668 kilowatt. And then for pump efficiency, we got the pump 1 efficiency is 51%, and pump 2 actually we got pump 2 efficiency is 87%. For the electrical consumption, as you can see here, we calculate the work pump per month, and then we got 1682.4 kilowatt. And then we use the commercial tariff table, we got 841.54 ringgit per month. For our water delivery construction, it is quite expensive, but is worth it because our water tank is quite big. And then we find the material for each component. We choose it wisely, and then we total up, and we got the total of the delivery construction is 3,204 and 58.6 ringgit.
So let me explain to you guys about our data analysis and discussion of our group members. So based on data analysis, we get that the volume of the whole system is 892.54 meter per cube. So our head losses we get from the calculation, which is 0.3246 meter, and our head pump is 2.84 meters, and head pump 2, which is 20.26 meter. So basically the whole work of our water and air pump, which is we'll get the 1682.4 kilowatt. So based on the electrical usage for our water delivery system, we get 841 ringgit 54 cent. So next we go to the discussion part, which is the location we choose is R&R Grand Patah, and we estimate that it has 10 toilets there, which is consists of 5 male and 5 female. So the consumption of one person is 5 minutes, so the total consumption of one person will be 15 liter. So we estimate how much of the person will be used in one day we get the 240% per day. So the water consumption will be used of the one single room of the toilet will be 240% times with the 50 liter, so we get the total of 3,600 liter. So the total consumption of all the toilet at the Arenat Gelam Patah will be 36,000 liter. So the water consumption also will be, the toilet also will be washed 1 hour per day. We get the 6 liter of the water consumption to wash the toilet. We get the 360 liter. So 360 liter will plus with the 36,000 liter, we get the total water consumption for the toilet at the Arenat Gelam Patah will be 36,360 liter per day. So next, for the pre-selection of material and equipment. So for the material and equipment, we got 8 of the most important part of the material. So first, we have here a flocculator. So for the flocculator, it helps to remove the solid from our wastewater by aggregating the contaminant into flakes. So it will be float to the surface of the water and will be settled at the bottom part. So they can also be used to dehydrate the solids and soften the lime. So next, for the sedimentation tank. So sedimentation tank, it will be transfer the solids to the subsequent treatments. In this big basin, you can saw here this circle big basin. So with the little bit of turbulence. So the primary sedimentation, it will remove the floating organic matter. So next, so for the water tank, we all know that water tank is to provide a space for our drinking water to be storage, to be used, and all of the treatment things. So for the intake screen, intake screen is used to filter raw water that has been taken from our surface supplies for many applications such as cooling water, processed water. So it will be taken from our Johor Straits, which is our main source. Next, for the flash mix tank, it is used to distribute the chemicals part like coagulant, H, chlorine and sulfur and other more. So this substance must be in slurry form to make it easy for neutralization process. So for the rapid dual media filter, it is efficiently used to remove suspended solid and pathogens. So it is need to reduce the turbidity of the RO feed water to be more slightly less than before. So next, bubble bath is the most crucial important material in our water delivery system because it is used as a throttling as well as on and off service, which is we can on our delivery system using this ball valve and we can off it to make it close. So next, for the polypipe HDPE, so this involving our water delivery system, we use this polypipe HDPE is most ideal among our discussion with our group member. So we choose this pipe because it is leak-free fuse. So it's one of the advantage, and it also can handle significant pressure, and it will do not rust and corrode, which will minimize our maintenance for our water delivery system. So that's all.
To conclude our project, from this project, we have learned about calculation and knowledge from mechanics course. We can conclude which pump to use and calculate using variety of methods. We also discover familiar concepts such as head losses and NSPH. This project also helps us to understand more about some topics in fluid mechanics. And as a future engineer, we are the one who are responsible in constructing, enhancing, and establishing an efficient system. That is all from us. Thank you so much.